very good morning, student. Okay, today we can continue the topic of physics, that is the gravitation. Okay, so the last time we have learned the Kepler's three laws of planetary motion. What was the first law? Every planet revolves around the sun in an elliptical orbit, with the sun at one of the focus of the ellipse. Okay. What was the second law? Law of equal area in equal time means the aerial velocity of the planet around the sun always remains constant. And the third law was that the square of period of revolution, that is the T, of a planet around the sun is directly proportional to cube of semi-major axis, okay, of its elliptical orbit, or T square is directly proportional to r cube. Okay, so these are the three statements of Kepler's that we have learned. So today we can come to the point, sir, what is exactly weightlessness condition in a satellite? Okay, so now point arises, sir, what is exactly weight? Okay, what is the exactly weight? So when you are talking about the weight of the body, so actually weight of the body is the force with which any body is attracted towards the center of the earth, or we can also say that the force with which the earth attracts body towards its center is called as the weight of the body, or that weight W is given by m into g. Now sir, if this is the weight, then sir, when we can say that the body do not have the weightless, we do not have the weight, or what is the weightlessness condition in a satellite? We are talking about the satellite particularly. So first of all, when a person, astronaut, is in the satellite, but satellite it itself in the rest position, we can consider in a such a situation. Okay, what is the weightlessness? First of all, why the weight is feeling by the astronaut when he is in satellite, but when he feels the weight, W is equal to mg, when that astronaut itself is in the, that means satellite, but satellite is in the rest position. Okay, satellite is in the rest position. Then what happens? The actually, when the astronaut giving the action force to the satellite, then at that time the astronaut will get the reaction force from the satellite. Why these things happens? Here, when he is on the surface of earth, his weight acts vertically downward direction. At the same time, earth's surface exerts equal and opposite force of reaction on the astronaut. Due to this reaction, astronaut feel his weight. Okay, are you getting this point? When astronaut is in the satellite and satellite is on the earth's surface, then at that time the astronaut giving the action force on the satellite and the satellite giving the action force to the earth, and meanwhile earth is giving the reaction force on that particularly satellite, means it which has been given by the satellite to that astronaut. So therefore he is feeling the weight. But now sir, what is the weightlessness now? Now when the satellite is revolving around the earth, then at that time he will feel the weightlessness. When he is in the rest position, then he has the weight. When what is the weightlessness now? When the satellite is revolving around the earth surface, that means then at that time what happens, you know? The astronaut is again in the satellite, but the satellite is revolving around the earth. Now what will happen? Here in that condition, satellite as well as earth, they have been revolving around the earth. So therefore, that means here in that case, astronaut as well as satellite having the same centripetal acceleration, because that satellite, why the satellite is revolving around the earth? Due to centripetal acceleration, and the same centripetal acceleration is, that means is on the astronaut, and so which is equal to acceleration due to gravity at that particular height. So therefore the astronaut cannot produce any action, okay, on the floor of satellite. Why this is in, why these things is happening? Because acceleration due to gravity at that particular height will be the same, and so therefore there will be no action on the floor of satellite by the astronaut. So the floor does not give any reaction force on the astronaut. Therefore, astronaut has feeling the weightlessness. Okay, what is the meaning of that statement? So actually, when the satellite is revolving around the earth, then at that time the satellite as well as astronaut, they are moving with the some centripetal acceleration. And which is that centripetal acceleration? G itself is the centripetal acceleration. So therefore the person itself cannot be acts any force on that your satellite. So therefore satellite does not give the reaction force, and result is that he is feeling weightlessness. Weightlessness means actually W is equal to 0. W is equal to 0. Mass of the body cannot be 0, but G can be 0 here. So how the G can be 0 here? Here in that case you see here, like as when the body is falling freely, then at that time acceleration due to gravity becomes 0. The same thing happens here. The satellite as well as the astronaut, what they are that means moving around the earth, so then at that time they are, that means falling freely, like as a zero gravity concept. The weightlessness condition is known as zero gravity condition. Thus the astronaut and the satellite are in the free fall towards the earth. Okay, so in the means here we cannot say that weightlessness does not mean that absence of gravity only G will be 0, but it's simply situation by which astronaut feel that he is not attracted by the gravitational force. So that is called as the your weightlessness condition on the astronaut from when he is revolving around he is in the satellite but revolving around the earth. Are you getting this point? Again I will define. When the astronaut is on the floor of orbiting satellite, both the astronaut as well as satellite are having the same centripetal acceleration, which is equal to acceleration due to gravity at that particular height. Therefore astronaut cannot produce any action on the floor of satellite. Therefore floor cannot exert reaction on the satellite. Therefore that astronaut in the weightlessness concept. Okay, so in short, why the weightlessness? Because what we feel at a weightlessness means only G is equal to 0, or weight of the body is 0. The center of at the center of earth weight is 0. So therefore weightless. Then same thing happens here on the that means in the space. But this is not the condition. When the satellite and astronaut is on the earth surface, so then at that time action is given by the astronaut on the earth. So therefore earth is also given the reaction force on the astronaut. So therefore he feeling the weights at that time. But when he is in the satellite but revolving around the earth, then at that time they both are moving with the same acceleration due to gravity, that is the G, and so therefore he cannot produce any action force. So therefore he is not getting the reaction force, and that is the reason why he feels the weightlessness. So this is a very important concept, zero gravity concept. Okay, now once you got that condition of weightlessness and satellite, then we are coming to the point, the communication satellite, which is the next point, communication satellite. Okay, so communication satellite. So you will learn what is exactly satellite. Satellite means the any artificial and natural satellite. Okay, artificial satellite means man-made satellite which has been sent by the man for his own purpose around the fixed orbit of earth, okay, to collect some information. So this is the your satellite, that is the artificial satellite. So one of the important use of that satellite is the communication purpose, and so therefore this is called as the communication satellite. This satellite is also called as the geostationary satellite, geosynchronous satellite. Why they are called as the geostationary or geosynchronous, that will come to that point. But sir, what is that communication satellite? Okay, then now first of all the satellite which is used for the communication point of view, therefore it is called as the communication satellite. But sir, what is that satellite particularly? The artificial satellite revolving in a circular orbit of Earth, okay, at particular height of 36,000 kilometer above the surface of Earth, okay, in a equatorial plane, okay, in a equatorial plane, that means about the polar axis, about the polar axis or about its polar axis means the line with joining the two poles. So that is the vertical axis, and about this axis in equatorial plane, the satellite which is going to revolve around the that means your Earth, and in the same direction of rotation of the Earth is rotated from west to east direction. The satellite is also set in such a orbit that it will also move in a west to east direction, and moreover the time period of that means revolution of or rotation of the Earth about its own axis will be the same as revolution of satellite around the that your Earth about that polar axis. So that satellite is called as the your communication satellite. Again, I will define the communication satellite is the artificial satellite which has been set in Earth's orbit above the surface of Earth at a distance of 36,000 kilometers. Okay, in such a way that the rotation of that satellite, revolution of that satellite is same as the rotation of the Earth about its own axis, that is the polar axis. This satellite has been set in equatorial plane perpendicular to the polar axis. Okay, so that satellite is called as the communication satellite. Okay, so why then this satellite is also called as geostationary satellite? Why this satellite is called as geostationary satellite? Okay, so bachcho log, geostationary satellite means the satellite, geo means Earth, with respect to the Earth's surface. If you observe that satellite, then that satellite feels to be a stationary. So therefore it is called as the geostationary satellite. Okay, relative to the speed of the Earth, if you can observe this satellite from the Earth's surface, then what will be the relative velocity of the satellite? That will be 0. So therefore it will be considered to be a geostationary satellite. Sir, why? Because both they are moving with the same direction, with the same speed, okay, and in the same time period. Okay, what is the time period of rotation of the Earth about its own axis? 24 hours. The same thing, the Earth, around the Earth, that satellite which is going to revolve, so that time period will also, that is the 24 hours. So therefore this type of satellite is called as the geostationary satellite. Okay, the relative velocity of that satellite with respect to Earth is 0. The relative velocity, relative velocity of satellite, with respect to Earth, is 0. With respect to Earth is 0. So therefore it is called as the geostationary satellite. Okay, so this, why that is geostationary? Because the satellite appears to be stationary from the Earth's surface. So therefore it is called as geostationary satellite. Okay, so now this satellite is also called as geosynchronous satellite. What do you mean by geosynchronous satellite? You can also tell me why this is called as the geosynchronous. Synchronization means what? You know, the both the satellite and the rotation of the Earth and the revolution of the satellite around the Earth are in the same direction, okay, with the same time period. So therefore they are the synchronization with each other. So therefore this is called as the geosynchronous satellite. Okay, its motion is a synchronous with the rotational motion of Earth. Okay, the motion of satellite is synchronous with rotation of the Earth, about its own axis. Okay, means motion of is synchronous, or motion of satellite is synchronous with the rotational motion of Earth. Okay, rotational motion of Earth, hence it is also called as geosynchronous satellite. So therefore they are called as geosynchronous satellite. What will be the time period of that satellite? So you will tell me now what is the time period. So time period of communication satellite is 24 hours. Okay, so like as How the time required for rotation of Earth about its own axis is 24 hours. So therefore, that satellite which is going to revolve around your planet, that is Earth, is taking the time of 24 hours. So therefore, it is called, that time period of that satellite is 24 hours. What will be the angular velocity? Angular velocity will be the same as angular velocity of rotation of Earth about its own axis, that is omega is equal to 2 pi by t. Okay, t is the time period of rotation of Earth about its own axis, so that will be 24 hours in second. 24 hours into 60 into 60, so that will be the 86400 seconds. So 2 pi upon this and then 7 into, so the 10 raised to minus 15 radian per second. So that will be the its angular velocity. So therefore, angular velocity of rotation of the revolution of the satellite around the Earth's surface will be the same as the angular velocity of rotation of the Earth about its own axis. Okay. And what is that height of that satellite? The height of that satellite above the surface of Earth is 3600 kilometer, and that is also called as approximately 6 times r. You know, r is 6400 kilometer. If I take 600, then 36,000 means 6 times r. Means what is the height? The height from the center of Earth, from the center of Earth, of Earth. So already height is r plus 6r. So therefore, and above the surface of Earth 6r. So therefore, total from the center, that height will be 7r. Okay, from the center, satellite point center of the Earth. Okay. Now once you got that, then now next question, sir, what are the necessary condition for motion of satellite, or satellite to be a geostationary? When we can say that this satellite is geostationary? So these are the condition only. That condition for the satellite should be, this satellite should move in an equatorial plane. Okay, what are the condition? Okay, can I rub this? Okay. Conditions of satellite. Condition. Okay, this satellite should be in equatorial plane. Equatorial plane. Okay, and which is moving in equatorial plane perpendicular to its polar axis. Okay. Second thing, at a height of 36,000 kilometer above the surface of Earth. Above the surface of Earth. Okay. Then third, time period of this satellite is 24 hours, same as the time period of rotation of the Earth about its own axis. Okay, about its own axis. Okay. And now that 24 hours means how much time? But you know, one day means 86400 second. Okay, 24 into 60 into 60. Okay, and the moreover, okay, direction of revolution will be same as direction of rotation of the Earth in anti-clockwise direction from west to east. Direction of satellite is also from west to east, which is the same as direction of rotation of the Earth. The revolution of direction of satellite will be the same as the rotation of the Earth about its own axis. So these are the necessary condition for the satellite to be a geostationary. It should be a geostationary or geosynchronous. The speed should be synchronized. Okay, motion of satellite is synchronized with the rotation of the Earth. Okay, so these are the conditions. Sir, what are the uses of communication satellite? Okay, it is for broadcasting telecommunication. Okay, it is used for particularly communication point of view. Okay, broadcasting communication. Okay, uses. Okay, broadcasting communication. Okay, yeah, TV communication. Okay, now for example, what do you mean by broadcasting? Okay, broadcasting communication. So suppose there is a match is going on in England and India versus England in England, and you want to see that match in India. So through the satellite communication, we can see that broadcasting, okay, or we can see that match very properly. That signals can be carried, okay, and that with the help of this antenna, the signals can be catched by this antenna. Then we are able to see that match. Means broadcasting communication point of view. Military communication, okay, military communication means here in military also some secret communications are going on, and for that this type of satellite can be used military purposes, okay, or we can say also military purposes. Okay, so that is the use of that satellite. Okay, weather forecasting and meteorological purposes. Okay, in weather forecasting, weather forecasting, okay, त्याच्यानंतर मेट्रोलॉजी डिपार्टमेंट, मेट्रोलॉजी, त्याच्यानंतर मुलांना टेलिव्हिजन कम्युनिकेशन, टीव्ही, ओके, and radio broadcasting, TV and television and radio signals over large areas with the earth surface, okay. For the GPS system, okay, it can be used for global positioning system. Okay, so these are the different uses of that communication satellite. Once you have learned that what is the geostationary, geosynchronous satellite, communication satellite, so there is another satellite. This satellite is revolving in an equatorial plane of Earth's surface, okay, from the west to east and perpendicular to the polar axis. But now there is another satellite which can be set in the polar axis, okay, and so that satellite is called as the polar satellite. Tasa mulanno, you have said here this is the communication satellite. The same thing, there is another satellite is there, and that is called as polar satellite. What is the name of that satellite? That is the polar satellite. आता हे polar satellite काय असतात मुलांनो? What do you mean by polar satellite? Okay, a satellite which revolves in a polar orbit. Okay, म्हणजे मुलांनो जसं तुम्ही सांगितलं की ज्यावेळेस एखादा सॅटेलाइट आपण हा जो होता पहिला सॅटेलाइट जो होता, हा समजा तुम्ही ही तुमची अर्थ होती मुलांना, ओके, आणि मग आता तुमचा हा इक्वेटर होता, आणि याच्या भोवती ज्यावेळेस तुम्ही तो सॅटेलाइट फिरवला असा असा वेस्ट टू ईस्ट, तर तो कोणता होता रे? कम्युनिकेशन सॅटेलाइट. हा त्याचा पोलार ऍक्सिस, ही ओमेगा. हा तर आता हा पोलार ऍक्सिस होता. हा जो सॅटेलाइट होता हा इक्वेटोरियल प्लेन मध्ये, इक्वेटोरियल प्लेन, मग याला तुम्ही कम्युनिकेशन म्हटलं, कम्युनिकेशन सॅटेलाइट. ओके सर, आता व्हॉट इज पोलार सॅटेलाइट? मग आता पोलार सॅटेलाइट मध्ये मी काय करतो रे, ही तुमची अर्थ सरफेस, अर्थ सरफेस. ओके मुलांनो, आता हा तुमचा कोणता, हा मधला पोलार ऍक्सिस म्हणजे हे इक्वेटोरियल प्लेन. ओके, हे तुमचं जिओसिंक्रोनस. ओके असं, आणि मग आता हा जो पोलार असेल तो अबाउट काय असेल रे? पोल असेल. पोलार दिस शुड बी अबाउट द पोलार ऍक्सिस, म्हणजे असा गेला पाहिजे. ओके, सो दॅट शुड बी फ्रॉम साऊथ पोल टू नॉर्थ पोल. ओके, एन टू एस, एस एन आहे, एन टू एस असा तो चाललाय मुलांना. ओके, एन आणि एस या डायरेक्शनने असा जो जाईल त्याला आपण नाव देऊन टाकू मुलांना. सो दॅट इज द इक्वेटोरियल ऑर्बिट. हे पोलार आणि हे इक्वेटोरियल. त्यांचा इक्वेटर आहे. ओके, याच्यावरती फिरणारा हा इक्वेटोरियल हा पोलार सॅटेलाइट. ओके, दॅट इज द पोलार सॅटेलाइट. पोलार सॅटेलाइट. मग आपण पोलार सॅटेलाइट कोणाला म्हणायचं मुलांनो, याची डेफिनेशन बघा. सॅटेलाइट विच रिव्हॉल्व्स इन अ पोलार ऑर्बिट. ओके, सो दॅट ऑर्बिट इज द polar orbit. Okay, the satellite which is revolving in a polar orbit, that is from north pole to south pole around the earth. Okay, the satellite which revolve in a polar orbit. Actually this orbit is perpendicular to equatorial plane. The satellite which revolves in a polar orbit. Okay, the satellite which revolves in a polar orbit around the earth. It's called polar satellite. So from north to south. Okay, so these are the two poles are there around which the satellite is going to move. Okay, and now this plane is perpendicular to the equatorial plane. आणि मुलांनो हे जे प्लेन असणार आहे ते कसं असणार आहे रे, इक्वेटोरियल टू द म्हणजे इक्वेटोरियल प्लेनला ते परपेंडिक्युलर असणार आहे. पण आता हे जे असतं मुलांनो, हे पोलार सॅटेलाइट हे लो ॲल्टिट्यूड असतात. ओके, दिस पोलार सॅटेलाइट्स आर perpendicular to equatorial plane. Okay, perpendicular to equatorial plane, low altitude. Okay, low altitude वर असतात मुलांनो. आणि याचा म्हणजे अल्टिट्यूड किती पण 100 किलोमीटर टू 800 किलोमीटर. सॅटेलाइट इज ॲट अ लो अल्टिट्यूड, दॅट इज द 500 किलोमीटर टू 800 किलोमीटर हा त्यांचा काय मुलांनो अल्टिट्यूड आहे. एवढ्या हाईटवर तो जसा अबोव द सरफेस ऑफ अर्थ किती होता रे, 36,000 किलोमीटर, तसा हा किती फुल लो अल्टिट्यूड. सो दॅट इज 500 to 800. टाइम पीरियड ऑफ पोलर सॅटेलाइट इज ओनली 100 minutes, is much less than geostationary satellite. Okay, time period is only 100 minutes. Okay, म्हणजे it is the काय रे मुलांनो, very less as compared to communication satellite. Okay, the earth is spinning in west to east direction. So much satellite can be the total surface of the earth. So it can scan the total surface of the earth. And polar satellite is also called as sun synchronous satellite. So that satellite was geostationary, geosynchronous. So this is called as sun synchronous satellite. This is the another name for that satellite is sun synchronous satellite. Okay, so now once you got that satellite, okay, so this is also mostly used for weather forecast. हा जर कम्युनिकेशन साठी वापरला असेल तर याला वेदर फोरकास्टिंग साठी वापरतात मुलांना. वेदर फोरकास्टिंग. ओके, वेदर फोरकास्टिंग साठी पर्टिक्युलरली दिस सॅटेलाइट कॅन बी युज्ड. ओके, आता मुलांनो हे झालं तुमचं कम्युनिकेशन अँड पोलार सॅटेलाइट. मग आता आपल्याला हा सॅटेलाइट सेट करायचा आहे, पण इट शुड ओव्हरकम द ग्रॅव्हिटेशनल फील्ड. मग आता आपल्याला ग्रॅव्हिटेशनल फील्ड काय असणार आहे त्याच्याविषयी बघू, ग्रॅव्हिटेशनल पोटेन्शियल विषयी बघू. ओके, मग आता आपण त्या पॉइंट्सकडे जाऊया मुलांना. सो फर्स्ट पॉइंट इज सर व्हॉट इज द ग्रॅव्हिटेशनल फील्ड. ओके, and then we can come to that point, what is the gravitational potential. So gravitational field, what is the gravitational field? Okay, the gravitational field means the space or region surrounded by any body around which any other body is going to be get attracted due to the gravitational force, okay, exerted by that particular body on the another body. So that is called as that region or that space is called as the field. Or we can also say that the imaginary region or space around the body in which the gravitational force of attraction can be experienced by that other bodies is called as the gravitational field of that body. Okay, so write down the imaginary, okay, kiti, okay, the imaginary, okay, the space, imaginary space, okay, or region, imaginary space or region surrounded in the imaginary region or space surrounded by the body in which, or space around surrounded by the body okay, or by in which the gravitational force of attraction can be, which the gravitational force of attraction gravitational force of attraction can be experienced by the other body. Okay, बघा रे, the imaginary space or region surrounded by the body in which the gravitational force of attractions can be experienced by the other body. Okay, other bodies is called the gravitational field of that body, is called gravitational field, is called gravitational field of the body. म्हणजे मुलांनो, एखाद्या बॉडीची ग्रॅव्हिटेशनल फील्ड म्हणजे काय रे, त्या बॉडीच्या भोवती अदर दुसऱ्या बॉडी ग्रॅव्हिटेशनल फोर्समुळे काय होतील, अट्रॅक्ट होतील, त्याला म्हणतात ग्रॅव्हिटेशनल फील्ड. सर, व्हॉट इज ग्रॅव्हिटेशनल पोटेन्शियल? व्हॉट इज द ग्रॅव्हिटेशनल पोटेन्शियल? ओके, व्हॉट इज ग्रॅव्हिटेशनल पोटेन्शियल? ओके, आता मुलांनो, तुम्ही जसं म्हटलं होतं ना, इलेक्ट्रिक पोटेन्शियल मीन्स it is defined as a unit positive charge has been brought near to, or the force experienced by the unit positive charge which has been bring from infinity to that particular point, that is the electric potential. Same thing, gravitational potential means the unit mass of a body brought near to the, that means particular the body from the infinity. The force experienced by that body, by the first body, is called as gravitational potential. So what is the meaning of that statement? तर परत याला एकदा सांगतो मुलांनो, आपल्याला एखाद्या पॉइंटला ग्रॅव्हिटेशनल पोटेन्शियल काढायचं म्हणजे काय काढायचं, तर आपल्याला त्याचं वर्क डन काढावं लागतं. इट इज डिफाइंड ॲज अमाउंट ऑफ वर्क डन in bringing the unit mass from infinity to that point. Okay, gravitational potential at any point, the gravitational potential at any point, is defined as the amount of work done, कसलं पण मुलांनो, it is defined as gravitational potential at any point is defined as the amount of work done to get unit positive mass from infinity, amount of work done to get the unit positive mass from infinity to that point. Okay, so that amount of work done to get the unit positive mass from infinity to that point in the gravitational field against the gravitational force in the gravitational field, in the gravitational force in the gravitational field against the gravitational force, म्हणजे मुलांनो, तुम्हाला ती बॉडी या ग्रॅव्हिटेशनल फील्ड मध्ये आणायची आहे अगेन्स्ट दॅट ग्रॅव्हिटेशनल फोर्स. सो दे आर रिपेलिंग अँड यू आर ट्राइंग टू गेट दॅट बॉडी फ्रॉम इन्फिनिटी टू दॅट पर्टिक्युलर पॉइंट. सो दॅट पॉइंट इज कॉल्ड एज द ग्रॅव्हिटेशनल पोटेन्शियल. आपण याला कसं लिहिणार मुलांनो? ग्रॅव्हिटेशनल पोटेन्शियल इज इक्वल टू अमाऊंट ऑफ वर्क डन पर युनिट मास. तिथे कसं लिहायचं मी? वर्क डन पर युनिट चार्ज. इथे होतं वर्क डन पर युनिट मास. ओके मुलांनो, मग सर ही किती राहील? वर्क डन म्हणजे फोर्स इंटू डिस्प्लेसमेंट. फोर्स इंटू डिस्प्लेसमेंट, फोर्स इंटू डिस्प्लेसमेंट अपॉन मास. मला ग्रॅव्हिटेशनल फोर्स माहिती होता मुलांनो. काय रे? GMM बाय आर स्क्वेअर इंटू, पण तो मायनस होता मुलांनो, डिस्प्लेसमेंट आर अपॉन ह्या तुमचा मास. आर आर गेट कॅन्सल, MM गेट कॅन्सल. काय राहिलं तुमचं? मायनस GM बाय आर. सो दॅट विल बी द ग्रॅव्हिटेशनल पोटेन्शियल. ओके, मग सर याचं युनिट काय असेल? वर्क डन पर युनिट मास म्हणजे SI युनिट is joule per kg and CGS unit will be ergs per gram. Okay, so these are the S and CGS unit. आणि मग मुलांनो, हे जे पोटेन्शियल आहे हे स्केलर आहे की वर्क आहे रे? इट इज द स्केलर क्वांटिटी. इट इज द स्केलर क्वांटिटी, स्केलर क्वांटिटी. मग याची युनिट मला डायमेन्शन सांगा बरं. वर्क डनचे डायमेन्शन आहेत तुमच्याकडे. M1 वर्क डन म्हणजे M1 L2 T⁻², आणि अपॉन मास आहे M1 म्हणजे काय झालं रे? M⁻0 L⁻², T⁻², M0 L2 T⁻². These are the dimensions of your gravitational potential. Last point, sir, what is the gravitational potential energy? So last point will be gravitational potential energy. Okay. Sir, आता gravitational potential energy means gravitational potential energy. Okay, gravitational potential energy. Okay, it is nothing but amount of work done. Okay, or we can also say that gravitational potential energy is nothing but it is the potential at a point at a distance of r from the point mass is known as gravitational potential. So gravitational potential energy at point is nothing but gravitational potential multiplied by mass. Okay, gravitational potential energy is equal to gravitational potential. Okay, potential multiplied by mass. So that product is called as gravitational potential energy. Or we can also say that that amount of work done, okay, is nothing but the gravitational potential into mass. So that product, and that is called as the gravitational potential energy, because this work done is converted into gravitational potential energy. So that is minus GM by R into mass. Okay, so therefore minus GMM by R, that is called as gravitational potential energy, minus GMM by R. Okay, so now why this negative sign has been given? Because when you are throwing the body up, so gravitational potential acts, that means force is acting vertically downward direction. So therefore this sign will be the negative. So you have to do the work done against the gravitational force. So therefore minus GMM by R. So that will be the your gravitational potential energy. What are the SI and CGS unit? SI unit is joule and CGS unit is erg. Okay, as this is the potential, gravitational potential energy. So therefore that gravitational potential energy have the dimensions of work M1 L2 T⁻². So these are the dimensions of your gravitational potential energy. Okay, our potential is equal to potential energy per unit mass. Okay, so that also you can say that is the gravitational potential energy. Okay, so or we can also say that potential V is equal to potential energy per unit mass. अभी जो आपने ये डिफाइन किया था बच्चे लोग, तो फिर इसको भी हम ग्रेविटेशनल पोटेंशियल एनर्जी हम ऐसे बोल सकते हैं. और वी कैन आल्सो से दैट पोटेंशियल, ग्रेविटेशनल पोटेंशियल is equal to potential energy per unit mass. So that is also the another unit of gravitational potential. Okay, so these are the your, that is all the field and potential energy. Next time we can see binding energy and escape velocity. Okay, today we'll stop. Thank you.